So in this lesson, we are going to take a look at some transformations of polynomial functions. Okay, so we're going to look at a few examples, and the first one we're going to look at is this function here. And just by looking at the function, look at the exponent, we can tell that the parent or the base function will be y equals x cubed. So we know we've got a cubic function here. So if we just start off by plugging in some values for x and finding some key points on our graph, we can graph the parent function. So if we plug in values between -2 and +2, get the following coordinates, and we can plot them on our graph and draw our curve. Just before we go any further, just wanted to briefly talk about describing stretches and compressions. So we're going to keep it a little bit more simple this year, and we're going to call that a value. We're just going to refer to it as a vertical stretch by a factor of a, no matter what that value of a is. And if there's a k value, we will always call that k value a horizontal compression. Just to compare, last year or in grade 11 we might have said that if a is greater than 1 we had a vertical stretch, where it was if a was a fraction less than 1 we had a vertical compression. And if we had a k value less than 1, so if we had a k value greater than 1, we had a horizontal compression, and if we had a k value less than 1, we had a horizontal stretch. So we're just going to simplify it a little bit for our purposes this year. So if we continue on with that example, so we want to describe the transformations that are applied to that y equals x cubed to get the transformed function. There we go. So remember to generally use the proper order. So the proper order is SRT, where S is stretches and compressions, R is reflections, and T is translations. So we're going to use that order as well. So we know that we have an a value that's half, so we're going to say for our purposes that we have a vertical stretch by a factor of half. So there is no horizontal stretch or compression, and there is no reflections. So now we can move to our translations. So we have a horizontal translation of 3 units, and remember when it's inside the brackets here, we change signs, so it's not 3 units to the right, it's 3 units to the left. And then at the end there we have -6, so we have a translation of 6 units down. So let's just complete the table of values here so that it will allow us to graph our transformed function. So we have our points for our parent function, and what we're going to do is, remember, we're going to do SRT is the order. So first thing we're going to do is we're going to apply that vertical stretch by a factor of half. So what we're going to do is we're going to multiply all our y values by half, which is the same as dividing by 2. So for example, we start off with -8, divide it by 2, we get -4, and so on. Then the next step will be to apply the translations. So we have to subtract 3 from all of the x values. Remember, when it's inside the brackets here, we're doing the opposite sign. So we're going to subtract 3 from all the x values. So originally we had -2, subtract 3, we get -5. And the last step will be to subtract 6 from all of the y values. There we go. So we start off with -4, subtract 6, so we go to -10. So now we have 5 key points for our new transformed function. And now we can apply those points to a Cartesian plane and graph them. So if we graph those points and draw our curve, there we go. So what are some of the features of our transformed function? So let's look at the domain and range. So we have a domain that can be any real number and a range that can be any real number. Point of symmetry. So point of symmetry is -3 and -6. And that's just the point that was originally 0, 0, which was the original point of symmetry. And that's the transformed point. Okay, so let's look at another example. So we've been given a function here. And again, if we look at the transformed function, we can tell that the parent function will be quartic, so y equals x to the 4. And again, I'm going to substitute values from -2 all the way to +2 so that we can get some key coordinates to graph our function. So if we graph those on the plane, we get our curve. So now we want to describe the transformations that are applied to our parent function to get the transformed function. So remember the order SRT. And one other thing here, if you look inside the brackets, what do you notice? There's -2x minus 8. So we want to be, if we're able to factor that, we want to factor that before we apply any of the transformations. So we can take out a -2 from this term and from this term. So if we factor, take out a -2, we're left with an x. Take out a -2, we're left with a +4. So now we can continue on describing the transformations. So the first one is we have a vertical stretch by a factor of half. We have a horizontal compression by a factor of 2. And we also have a reflection in the y-axis, or a horizontal reflection. Now we can describe our translations. So we move horizontally 4 units to the left, and vertically we move down 2 units. So let's do the same thing as before. We're going to use a table of values, start with our parent function, the key points, and we're going to change those key points. So the first thing we're going to do is apply the vertical stretch by a factor of half. So we're going to multiply the y values by half. So 16 times half is 8. 1 times half is half, and so on. Next we're going to do this reflection and compression all in one step here. So we will divide our x values by -2. So if we start off with -2, we divide by -2, we get 1. -1 divided by -2, we get half, and so on. Then we can apply our translations. So remember, it changes sign. So we subtract 4 from the x values. So we start off with 1. We end up with -3. For half, take away 4, we get -3.5, and so on. Last step, we subtract 2 from the y values because we're going down 2. Start off with 8, subtract 2, we end up with 6. Positive half, subtract 2, -1.5, and so on. So now we have all the key points, and we can graph our transformed function. Okay, so we're going to plot those key points and draw our curve, and that would be our transformed function. So let's look at some of the features of that. So domain and range. Go back. So our domain would be any real number. In our range, we would have a restriction. So we could have any real number, but it must be larger than this point here. So what this point here is, it must be larger than negative 2. So if we look at the equation of the axis of symmetry, so that is x equals negative 4, and our vertex, negative 4, negative 2. So just to summarize the key concepts here, so the A value, vertical stretch or compression, K value, horizontal compression or stretch. D value is the horizontal translation left or right. Remember, it switches signs. And the C is the vertical translation up or down. And what we can do is apply those changes to key points from our parent function to get the new points of our transformed function. So what we're going to do here, just make a general mapping. This is called a mapping diagram. So we're going to take our initial point from our parent function, and in order to get the new point, we divide it by k, and then we're going to add or subtract the value of d. We're going to start with our y value. We're going to multiply it by a, add and subtract c. So for this function here, we're starting out with x and y. So we're going to divide by negative 2. We're going to subtract 4, because those are the horizontal transformations. And then for the y values, we're going to multiply by half and subtract 2. So any point on the parent transformation can be changed using this mapping formula that we just created.
Wow!
So just a quick note for transformed power functions. Even degree functions have an equation of the axis of symmetry and a vertex. Odd degree functions do not have a vertex or an equation of the axis of symmetry. Odd degree functions have a point of symmetry. And that is the end of the lesson.